Okay, number 9. There are a couple of questions like number 9. On this particular one, we have N2N2O5 breaks down to give 4 NO2 plus 1 O2, and it's all in the gas phase. They give us the rate of consumption of N2O5. So the change in N2O5 with time is its rate of change. But because this is a reactant, I would have to take the negative value of that to get a positive value, of course, for the rate of its consumption. And in number 9, they tell us that the rate of the consumption of N2O5 is 1.2 times 10 to the minus 4 moles per liter, or capital M, per second. And we are asked to find what is the rate of production of oxygen. So for any question like this, the best thing that we can do for this and any question like it is to write the rate of the reaction in terms of each species, whether it's a reactant or a product. And there is a standard way of doing that, you'll remember from lecture. We take the stoichiometric coefficient and we make it a reciprocal. And that becomes a negative for reactants. And so the rate of the reaction in this case is equal to minus 1/2 times the rate of change of this reactant, N2O5. And I can write it in terms of each product. And again, the 4 will become a reciprocal, but this time it's positive because NO2 is a product, times its rate of change. And the triangle is just delta, it means a change. And that is equal to, well, 1 over 1, but I just won't write anything. And that's O2 pi time. And so now we can see very clearly that the rate of production of oxygen is equal to minus 1/2 the rate of consumption of N2O5. We can see very clearly. So what they're asking us for is this, and that is equal to minus 1/2 times the rate of change, or rate of production, with the rate of consumption, of the N2O5, and that is equal to this. All rates have to be positive, and so that's why we use the negative sign, because the rate of change of reactant will naturally be a negative number, but all rates of reactions and rates of consumption and rates of production, they need to be positive numbers. And so that comes out to be 6.0, we'll push the decimal place over, times 10 to the minus 5. And if you look on your sheet, the answer to number 9, therefore, is C, 6.0 times 10 to the minus 5. What's important to remember, though, is that for a question like this, any question like this, what you want to do for yourself is to write this right here so that all the answers are basically in front of you. For example, they could have asked what is the rate of production of NO2, and that 4 would have been brought to the other side, and so on. So we just need to do a little bit of algebra, and we can isolate any rate of change of any species, either reactant or product. Okay, let's stop it there for a moment.